Hello everyone. Nima is here. So today I'm gonna continue the discussion that last time I started about the domain-driven design. So first of all, before we start the domain-driven design, this kind of things again, I would like to thank you all of you for supporting the previous video. I never thought that I get this many views and this kind of things, and the thing is growing. The watch time is growing exponentially. So thank you all of you. So to give back, today I'm gonna discuss about the dependency injection. So if you guys know me, I'm a very big fan of dependency injection, and I tried my best to put a very good presentation about A to Z of the dependency injection and this kind of things. So this one, it would be only the introduction about the dependency injection. So I will explain about from zero that why dependency injection and this kind of things and why not dependency injection, everything. But I recorded this video. This is the second time I'm recording this video. The first time it took a very long time. So if you want to know in depth, this video is for you. But I will try to do my best. Okay. So this one would be only introduction because it's too long. But after this video, I will do another video that I just show you a simple demo, and I'm thinking to make another video. Although I'm gonna discuss the dependency injection itself in this video as well, okay, but I'm gonna do one more video on very depth about only dependency injection. Because in this video at the beginning I will explain first about the main problems that dependency injection is gonna solve. So this is the reason that the video will become too long, so I'm not gonna spend too much energy on the dependency injection a lot in this video. So yeah, so I hope you guys enjoy this. Let's go and get started. So I'm teaching the dependency injection for sometimes to many people. So every time I want to discuss about the dependency injection, dependency injection is like a plate of sushis, and it is very important. This metaphor is very important. Later I will explain just why I say plate of sushis. Okay, the plate is important, the sushi also is important. Okay, so I stay tuned to know why I say plate of sushi. And the normal approach that most people they take is like spaghetti. Okay, so let's discuss before that. Before we start, let's do about first about discussion. So why we want to do the dependency control? Okay, forget about the dependency injection. Okay, why the dependency itself it matter? Okay, why we need to have dependency control? Okay, so first the first objective is that we want to be flexible. So we want to be able to move things around. Okay, so replace things. Okay, because the only constant in life is change, and for the software engineering this is even more true because things is keep changing. After that the packages they become obsolete. We have EOL, end of life cycle, and beside the things is changing, something new cooler come. For example, this UI is beautiful, tomorrow another type of button it become trendy. So you want to be able to keep change things. Okay, so that's the reason that you need to be flexible. Things become maintainable. Okay, so when you are doing the when you don't do the dependency control, and for example you have a spaghetti code, it is not really maintainable and there is a lot of hardship about it. So dependency control make things more maintainable. Later in the when I'm discussing, I will give a lot of example about the maintenance. Next thing is testable. Okay, so if you are, for example, writing something for yourself, for example, and the duration of the project, for example, is 1 month, and you are living in your mom's basement, test it doesn't matter. Okay. However, when, for example, you work with a team of hundreds of people, or you're working in a, for example, open source project that you don't know even who the end user it is, okay, what will happen to you is that test it become important, especially when you want to do the project for a very long period of time. For example, 1 month. For example, from 1 month, you, for example, push it to, for example, 10 years. Okay, even yourself, you don't remember 10 years ago what you did. Okay, so tests are the safeguard of you to make sure that the thing it is perfect. And dependency injection, dependency control, those kind of things, especially dependency injection, bring a lot of values to the table when we talk about the testability. Okay. Later I will explain again. And scalable. Okay. So at the end of the day, we want to earn money, right? So if the things is not scalable, we cannot to ship, we cannot to build the next Google or Apple or something like that, right? So dependency injection helps a lot about the scalability. Okay. So before we go further about the dependency injection, so I do two objections that you have to know before doing the entire presentation. Okay. First of all, okay, dependency injection. Okay. Although I say a lot of good things about dependency injection. Okay. Dependency injection involves a lot of boilerplate. Okay. And it is not meant to be for something very small. So this is a very basic and minimum. Okay. And what I'm trying to emphasize in here is that, and this is one thing, and another thing that it is that no solution, it is not a solution to everything. Okay. So there is a quote that I really like, and he say that, okay, to a man with a hammer, everything is a nail. Okay. Dependency injection is not a hammer for every nail. Okay. So for example, dependency injection is something that, for example, it helps you to do the decoupling and those kind of things. So for example, they are not the only solution for decoupling the, for example, your codes from each other. For example, message buses, they are one of them. For example, mediator in a C# word, for example, is another solution that it is helping on this kind of thing. And for not everything you need a dependency injection. For example, for something like for example, Google extension. Okay. For something like a Google extension, for example, it is for example 100 lines of code. For example, dependency injection itself just take 50 lines of code. So for something like a Google extension that it is 50 to 100 lines of code, and dependency injection just doesn't make sense. Okay, so now that we know the good and we know the bad, okay, now the bad thing about the dependency injection and the good thing about dependency injection in the further down the slides, I'm gonna break it down way even further. However, for appreciating, because a lot of people, they even use the dependency injection, but they don't appreciate it. Okay, well, they don't appreciate what it brings to the table. For you to be able to appreciate the dependency injection, you have to know the history of the thing, why we reached to the place that we do dependency injection, where we started, and how the thing it progressed, that now dependency injection it make a huge sense. Okay, so for doing this, I will do the different scenarios. I will tell the scenario. After that, I will say that what is the problem with the scenario. After that, I say that how the people solve it. After that, I say that what is the for example, the drawback of the next one and the drawback of the next one, and what is the good things about the next one. After that, we keep progress until we reach to the dependency injection itself. Okay. So the path that we want to go, or the route that we want to go, it starts with the tightly coupled dependencies. After that, I talk about the child depending on the parent, the God object anti-pattern. I will talk about God object anti-pattern. Okay, so this one I'm gonna discuss a lot in detail. After that, I will talk about the decoupling via callback functions. After that, I will talk about the callback function derailing. And the last thing that I'm gonna go is the dependency injection itself. Okay, so if you are here only for dependency injection itself, this video might not be for you. Okay, or you just can go until the last chapter. I will try to make this one chapter so you can just see the last chapter. But if you are here for a long haul and you want to know from A to Z in very depth, okay, it's not for, I'm not gonna say that this video is for beginners. I would say that this video is in-depth view of the dependency injection. Okay, so why and why? Okay, why, and for example, I give a lot of case study that, for example, you do this happened, or I did this happened, and this is why you have to do this, and this is why you have to do that. So this is the reason that you can skip, and even I will try to do another video only about the dependency injection, how the dependency injection itself, okay, benefits of the dependency injection, and the next video after this would be a tutorial, hands-on tutorial. Okay, but this one is more about the understanding and the basic things. Okay, not the basic thing, about the understanding and visualizing the thing. One thing that I understand, because I'm teaching the dependency injection, I have taught dependency injection many times in my life. To be honest with you, teaching dependency injection, my success rate was all these years was very low. Okay, and the reason that it is that because the very few people they can imagine how the dependency injection is in the real world. Okay, even that they cannot to visualize it. Okay, and the ones that they do actually they become very successful. Okay, of one of you are one of those guys. But many people they don't understand, and even they understand they do still stupid mistakes that even that they don't use the dependency injection in a proper manner. Okay, because the dependency injection does not solve all the problems as I mentioned earlier. Still, you can do something like a circular dependency with a dependency injection, or even, for example, dependency derailing or something like that. It still can happen. Okay, it is only a tool. It reduces the happening of the percentage of the time that these things it happens, but it does not remove it all. Okay, it still is up to you to use the tool properly, and for using this tool properly you have to understand it very well and visualize it very well. Okay, so I hope you guys understand this very well. Okay, so let's start. Okay, so first of all, so the mind map now that you are seeing that I'm doing the presentation will be linked down below. Okay, beside that also I did a blog. I haven't published it, but by the time that this video is done, I'm gonna publish it with the video together. So the source code, look at it here, because the source code here is quite small, so you may not see it very properly. But you have to use these documents together. This one is better for visualization. That one is for coding, is much easier. So I did a lot of presentation to help you to visualize the dependency injection. So we go from a very simple code. Okay, so simple dependency. Okay, and with tight coupling. Okay, so the simple dependency looks like this. So let's look at it how the code look like. Okay, so I just have a parent, that this parent is dependent to a child. Why I say is dependent to a child? Because you see, in this parent I have a child, right? And I instantiate the child, and after that I will call this child inside myself that is inside the parent. Okay, so this one is a simple dependency, and this is a tightly coupled dependency. I cannot to remove the child. If I remove the child or I change the child, I have to change the parent. Okay, so it means that the parent without the child will gonna die. Okay, supposed to be, you cannot to have the parent cannot be exist without the child. So this one is a hard coupling. Okay, so if you want to visualize this thing, okay, so it would be something like this. Okay, the parent, it is dependent to the child. Okay, so first of all, so before we go to the problem with this thing, okay, this one is very important to understand. Okay, this is not a bad thing all the time. Okay, this is okay for simple stuff. This is okay. Okay, for example, if you do an extension or something like that, or for example in UI stuff, you don't want to, for example, wrap everything. You don't want to add dependency injection to everything. Okay, for something simple, okay, this is more than enough. Okay, but this thing, it does not, what I want to say is that this thing does not scale in bigger cases. Okay, and in some cases this is not making sense. Okay, so the question is, in which cases this thing it does not make sense. So the first issue with level, let's mention the issues with this thing. Okay, this thing is very hard to maintain. If you want to change the child, you have to change the parent. Okay, so if you are in .NET framework, although I'm doing this one for TypeScript, also for TypeScript, you don't have the issues, for example, like us, for example, compilation, this kind of thing. I mean, for example, in the JavaScript world, for example, the compilation, this kind of things is totally different case. But for example, if in a C# world, okay, if, for example, you change something that you are dependent to, okay, although you didn't change, and for example, imagine a library that you use that there is no changes or for example, on none of the things over there it make you it impact on you, okay, but when you compile that guy, you have to compile yourself, okay, so it means that it makes the compilation problem, okay, and okay, maybe you say that okay, so this is not an issue, okay, so why you have to care? In big projects, this is a very big matter, okay. What does it mean for a big matter? It means that in the big projects, so for example, if for example you have to do a series of the compilation, okay, uh, it make a lot of issue because for example sometimes you don't have access to those library, okay, for example some of those libraries is behind walls, okay, they are behind closed doors, okay, you don't have a right access to for example those libraries, so you cannot to do even the compilation, okay, you have to get a lot of for example permission from your manager, this guy, that guy, and you know a lot of headache, okay, so just what I want to try to tell you is that okay, when it comes to the dependency, okay, don't make life difficult for you. Okay, just do the proper practices and care about the dependencies. After that, you will have less problem, make the things maintainable and those kind of things. So, but okay, this is the first problem. Okay, the second thing is about this one is inflexible. Okay, you cannot easily replace the child because they have a hard dependency, right? If you want to replace the child, okay, you have to definitely change the parent, okay, because he is the one that he is creating this child, right? So instantiating the child, right? So it will create a lot of problem for this parent, okay. So and another thing that it is that in this tutorial, in this video, you have to understand that who creates the child and how the child is constructed. It is very important, okay, how the child is constructed, for example, how the dependency is constructed is very important, and this is the reason that we care about the dependency injection. I will explain more in the future in the rest of the video. So and next thing, this is difficult to test, okay. Why it is difficult to test? Because the thing that it is that now that for example you have the child, okay, you cannot do, for example, okay, for I give you the best, I give you a case study, okay. During the time that COVID happened, okay, I was working on a machine, so I was in semicon, okay, I was doing the UI for the semiconductor manufacturer for many years. So what happened in the COVID is that I have to work with the machine, right? We are building the machine, right? But we are locked down. We cannot go there, right? So the thing that it is that, for example, imagine you have a class that it only works in the production environment, okay? And you are, for example, and you used to do, for example, leave to production environment because you are working in a factory, right? So what it happens is that now that it is locked down, so you cannot access to the guy, right? So you will die, right? So the only way that it is that you have to somehow simulate the guy, right? Because maybe the guy does not do anything important, right? And this is the reason that I'm very heavy in test-driven development, and I believe in test a lot. Okay, is actually I started to do test development since the beginning of the COVID. When they locked down the factories, I had no choice other than doing testing because I couldn't access the resources that we used to. Okay, so I started to do the test-driven development, and this guy, okay, so for example some dependency, some hard dependency like the one that I show you, okay, it is nightmare if you want to do test-driven development, okay, because you are dependent to it. You cannot to keep, for example, go there after that, for example, comment your code after that, switch it, this kind of things, or for example put a switch case statement, okay, switch if for example simulation environment this, if for example not simulation environment, so these things is not practical, right? So anytime you add unnecessary code, you have to maintain it, right? So this is horrible for test, okay. However, again, okay, before we go to the next one, I want to reiterate, okay, keep it simple, okay. This is, although it is, I say that all these bad things, for simple stuff, this is more than enough, okay. For example, for something like UI, you don't want to have a dependency injection or something like that, okay. This one, it will do, and this is more than, okay. However, this is not the main fundamental issue of this one that it breaks things, okay. The main fundamental issue of this one is the next case scenario, okay. Actually, this is the solution to the next case scenario, okay. The problem is that sometimes not only the child parent is supposed to access the child. Okay, sometimes child want to access something in the parent. Okay, so for example, something like this. Okay, parent asks you that, for example, okay, would you like, for example, to have an ice cream? You want to respond to the parent that, okay, buy me an ice cream. Okay, so you have to have some way to communicate to the parent, right? So for this one, you need a two-way communication. Okay, so one simple approach to solve this problem is doing something like this. Okay, what does it mean, this thing? The parent, okay, so that, for example, this one is a parent, this one is a child. Okay, you can pass an instance of yourself, you can pass yourself to your child. Okay, so for example, this one is a parent, after that this one is a child. The child, he will get the parent, it means you, and access to you. Okay, so how do you do that? It means that you pass yourself to the child and the child can access to all your resources. Okay, so what does it mean? It means that the child is also dependent to the parent. Okay, so this case scenario, it means that the child is depending on the parent. Okay, first of all, this is a horrible thing to do. Okay, so okay, this one is not like the previous case scenario. If you do this, okay, you are doing something bad. Okay, don't do it. Okay? I will tell that what are the issues with this one. Okay, what are the problem with this scenario, child? In this scenario, the child directly, and another thing also, there are proper way to handle this kind of problems. Okay, if you are from the JavaScript world, you definitely know these kind of things because it's very common in the JavaScript world, the solution to this problem. But if you are, for example, from other background, yeah, so maybe this one, it doesn't come obvious to you that how to solve this kind of problem. In this scenario, the child directly depends to the parent. Okay, the parent passes itself to the child, making it aware of and dependent on parent's method. Okay, this one is very important. Okay, the child aware of and dependent on the parent's method. Okay, it means that, for example, imagine, okay, I'm a parent, I'm a father. Okay, my wife have to have access to my wallet, right? Okay, so this one is something that makes sense. Okay, but however, if I pass myself to, for example, my child, okay, is it okay also my child access to my wallet? Okay, imagine I have $1 million, for example, in my pocket. Okay, and my children like ice cream. Okay, he can go and buy the ice cream factory with your wallet, right? Without your permission, right? So this is not okay, right? This leads to bidirectional coupling, which further complicate the design. So this one is true. It is very difficult to reuse the child or move things around. Okay, so this one is even more true. Okay, so now the thing that it happens is that now they are very tightly coupled. Every time you want to, for example, okay, previously when, okay, in the previous method that I mentioned in this one, okay, when in this one still you can move around the child, you cannot move the parents. Okay, so the parent, it depends on the child. Okay, but the child is free. Okay, he doesn't have any dependency, so he can do whatever he wants, but the parent does not able to do whatever he wants. Okay, but in the second one is even worse. Why? Because, okay, the child is not free, he is dependent to the parent. Okay, the parent also is not free, it is dependent to the child. Okay, so yeah, this one is not okay. Okay, this one is not okay. They are very tightly coupled together. Okay, so tight coupling. So this one, it means that what, they have a tight coupling. They try too much, know too much about the parent. The wallet case scenario that I said, any changes in the parents will affect the child and vice versa. So this is the second problem. Okay, not only that you can access to the wallet of the parent and buy yourself a ice cream factory. The second problem that it is happening for you is that, imagine your parents, for example, want to change. Okay, the child's supposed to change, and if the child want to change, the parent's supposed to change. What does it mean? It means that, for example, something like this. Okay, so now put it in a real world context. What it happened is that, imagine, for example, you have a factory, and for example you have a vendor, and you are tightly coupled with this vendor. Okay, it happens. Okay, so for example, in one of the places that I was working, okay, we were a supplier, for example, to to a customer. After that, our company the company started to do some misbehaving, and we had no choice. Okay, what happened is that we supposed to deal with them. Okay, so we have to support them anyhow. So this was a very big problem. Okay, so because the things is it was tightly coupled. If, for example, they start to, for example, if we stop, for example, supplying the products to them, they die. And if, for example, they don't buy from us, we die, because, for example, we have a loss of inventory and those kind of things. So we were tightly coupled together. But if we were not tightly coupled together, we could easily survive this case scenario. It is hard to maintain. You need to manage both life cycle together, which reduce modularity. Okay, so it means that, for example, you cannot to, for example, it is not like a sushi. You cannot to separate them one by one. Okay, you have to always use them as a bond. Poor flexibility. Again, the same scenario. They are again all these cases. Is there a better approach to do the decoupling? Yeah, definitely. So we will discuss those in the future. Okay, so let's discuss about an even worse case scenario than that. Okay, the God object anti-pattern. Okay, if you do this, okay, if I am your child, okay, you can remove me from your view. I don't want to be your child. Or if I'm your parent, I don't want you as my kids. Okay, so the God object anti-pattern is a very big problem. Okay, and it is very horrible to for companies. Okay, so before what is the God object anti-pattern? Okay, so the God object anti-pattern is something like this. Okay, there is one central object that all the children that, for example, they are created, and everything is depend to this single object. Let me show you in the code how these things look like. If you see the code, the anti-pattern, for example, the God object is something like this. Okay, there is a parent component that all the objects they are constructed in this parent component. Okay, and all of them, for example, you see, for example, all of them, you pass the parent to all of them also. Okay, so these kind of things, right? You see all of them, right? So all of them, for example, they have, for example, they passing the this. Okay, so it means that you passing yourself to all of them. Okay, it means that not on, it means that this on the God object, okay, is the worst case scenario of the first case. Okay, so in the God object, you don't need to, not all the, for example, not all the children, for example, you need to pass the instance of yourself to them. Okay, so sometimes you don't pass all to none, you don't pass to all of them, but what happened is that the object creation to all of them, it happened in one location, in one central object. Okay, forget about the decoupling. Okay, forget about decoupling, dependency injection, these things. Okay, this thing is absolute nightmare. Okay, so, and you have never ever do this, never ever do this. Okay, if you do if you living working for a company that they do this, okay, leave the company. Okay, that company is not a good company for you. And this is a very red flag about a company. Okay, why this is not good? Okay, the first issue with this thing that is happening is that before the decoupling, this kind of thing, okay, memory leak. Okay, so if, for example, they do the first of all, for example, all the instances that you create for this child is alive all the time. What does it mean? It means that the life cycle, it means that if, as long as this application is alive, all the children supposed to be alive, right? So you don't remove them. So you use a lot of memory when you do something like this. Okay. Besides that, if you do you do these things dynamically, it means that you keep creating, removing those kind of things on the parent component or something. You will definitely have the, for example, you could have memory leak, those kind of things. So yeah, so these things is a horrible thing. Okay, never ever do this. Never ever do this. Okay, so yeah, so this one is only for example, about just only the children and those kind of things. So later I will explain these things even further. So both sides, they are having access to this. Okay. The configuration also is looks something like this. Even that the parent is kind of this one actually is this one is the one that I find from the internet is the best drawing of the thing. Okay. So first of all, before you do this, you may ask that why people they do this. Okay, so the reason that they do this is that because they want to access to here is very simple. Okay, very simple solution to do these things. Okay. So what I would say about the God object pattern, okay, always every time I want to teach this one, the God object pattern, it is like a frozen spaghetti. This is the best example. It is a spaghetti, okay, but it is frozen. It means that you cannot move it. You can do it. This is the whole thing. It means that because everything is constructed in a single object, what will happen to you is that if you want to move a part, you have to move the entire thing together. Okay. Uh, Actually, I have a very bad experience with this one. So in one of the projects that I was working, actually, I was working on something that it was like this. Okay, so it was there was an object over there. The name of the object I will never forget. The name of the object is the app. So this object that it is called the app was used for over 2 decades by hundreds of engineers. So many classes inside. Okay. And I just tell you like this, okay? They can never fix that. This thing they can never fix it. Even that they can never because later I will explain why they can never fix it. Okay. What is an issue? Okay, so let me explain what are the issues with it. This one, zero reusability. Okay, because why? Everything is coupled together, so you cannot do not there is not a single object that, for example, imagine for example you want to abandon this project, okay, and go do another project, okay. You cannot take away a single object, okay, that it is coupled to the God object, okay, without without modification. Okay? I would say like this. Okay, let's say for example you do for example refactor a little bit here and there. Maybe for example you can do some Tai Chi. Okay, but the thing that it is that if you want to go and start a new project, okay, you cannot bring any of the code, okay, without a modification. Okay, and that is horrible. It is extremely difficult to extend. Okay, the parent it become increasingly difficult to modify and risking breaking to the other part of the code. Okay, so this one actually it is not only a coding problem. Actually, this one the God object it become a psychological problem. Later, I think here I explain. Okay, when you do this, okay, because the thing is keep broken very often, so people they start scaring to change things because the things keep get broken, this kind of thing, you will see a lot of duplicated code because people they are scared to change. Okay, because they are scared that they break the thing, so they keep duplicating code. There is no maintenance. Okay, uh, fear. The main issue is fear. Okay, people they get start to becoming very fearful. Okay, and the business will die eventually, but we will reach to that. Okay. Another issue that you will have is a circular dependencies. For example, you have an object A. After that the object A is connected to object B. Okay, and the object B is connected to object A. So if, for example, object A, for example, need the object B to be initialized, okay, and the object B is need that the object A become initialized, okay, so they will never initialize. So this one is the dependencies. This one, the circular dependency like this is become a nightmare. Okay, another issue is deadlocks. Okay, so imagine for example object A and object B, both of them they're using a shared resources. Okay, so first of all, for example, okay, if you need a shared resources or something like that, for example, in for example in the parent component, I mean, so for example you can still do the semaphores, those kind of things, but the semaphores also, for example, you have to know what you do, and not everybody can handle these things very well. You can create deadlocks, those kind of things, these another weird problems, you know. And by the way, the object A and the circular dependency that I mentioned in here, this one is a very simple case scenario A and B. Okay, in the real life is never like so simple A and B. You know, normally A go to C, C go to D, D go to F, after that F come back to B. Okay, so yeah, so it is not like this easy. You can find out, for example, how the circular dependency is happening. Over centralization parent to know too much to control, this makes it a single point of failure. Yeah, so this one also a very important thing. So imagine, for example, an exception happened, for example, in the parent, okay, and the parent shut down, the entire system shut down, okay, the entire thing will crash. So, but for example, if for example there are better ways to handle this. For example, if for example they were separated, for example, if they crash in a small part of the, for example, if for example they were multiple objects, just failure of one object does not crash the entire thing, but this one it will crash the entire thing. Poor separation of concern. The parent is responsible for too much job delegating, managing, and this one is, so this one is not the important thing. These things lead to fear. Okay, it means that the parent is too complex. The complexity of the code. The issue is the psychological thing of this. Okay, so it causes fear, and when things become fear, you never change. Okay, and you need to change. Okay, the only constant in life is change, and in for software programming this one is even more important. Why this thing is even more important? Because the UI that you were using 10 years ago, when for example internet just pop up, okay, is it similar the thing to you see today? No, it's not, right? So you have to keep changing the thing. But when the people become fearful to change things, can you do that? No, you cannot do that, so you die. Okay, so you die. Okay, and besides that, also, for example, even for example, you said that, okay, I'm a Craigslist. Okay, I don't care. Okay, my UI is ugly. Okay, but the thing that it is that if you are, for example, somebody like Craigslist, okay, your UI still does not kill you. Okay, but for example, previously in the previous jobs that I work, so for example, we have a very hard dependency that we die with it. Okay, and after that the supplier EOL, that is mean end of life cycle. Okay, so what happened to us? It was that we had 6 months, okay, to change that dependency that we were relying on for the past 15 years. Okay, in 6 months we have to change it. Okay, or we go out of business. Man, you don't want to be in that scenario. Okay, I remember we were working 7 days a week, 15 hours a day. Okay, a team of 7 people. Okay, it was a it was one of the most difficult part of of my life. Okay? So, and I was sick back then also, for example, not all the time you are healthy, this kind of thing. I back then I had the Bell's palsy, half my face was numb, this kind of thing, and I still forced to work. Okay, I don't want to dramatize the situation. Okay, but always keep dependency control, dependency, this kind of thing, seriously. Yeah, it make things serious. Okay, for example, just now the early case scenario that I told you. Okay, for example, memory leak or those kind of things. Okay, in an embedded world, okay, something like a memory leak, okay, can kill people. Okay, something like a memory leak can kill people. Okay, so don't do this. Okay, whatever you do, don't never ever never. Okay, so just remember this: never ever ever do the God object anti-pattern. Okay, never. Okay, so this is horrible to do. Is a crime as killing people. This is terrorism. Yeah. Okay. So let's go to the next one. So let's talk about the callback solution. So if you are from the JavaScript world and this kind of thing, so since this one is a TypeScript coding programming, so definitely you guys have seen the callback solutions. So the callback solution, they are better. Okay, although you have some dependencies, but the dependencies, they are not hard dependency. You see, I put dot 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 dot, right? So what does it mean is that because they connect together through the callback function, you can still decouple them. It means that you can take the child separately and after that parent separately, and after that, for example, do something like that. So you have two ways. Sometimes the callback function methods, some of them they are single way, some of them they are dual way. Okay, so the single way is a common one that we always see. So I already prepared the code for both of these case scenario. Okay, the one way is something like this. Okay, the child this is, for example, this one is a child, okay, and for example, this one is the parent, okay. So the parent have some, for example, function that can pass to the child, okay. If you see the child, he will accept a callback function in his constructor or whatsoever, okay. So in his function or whatsoever, okay. So he get the callback function, after that do the, for example, he call the parent or whatsoever, okay. So this is very common in the JavaScript world, right? So it means that, what does it mean? It means that the parent, he passed the callback function to the child, and after that the child call the parent function or whatsoever, okay. So this one very common, okay. So this one is a one-way method, okay. So you can have two-way method also, okay. It means that they're something like this, okay. So for example, the child, okay, asks something from the parent, and for example, the parent also uh, asks something from, for example, the child or something like that, okay. This one is the parent, okay. So you see, for example, the parent also, they have the callback function. It means that this guy he give his callback function, and that guy he give back his callback function, so they have a two-way communication like this one, okay. So this is not something you commonly do, okay. If you do a lot of things like this, yeah, I'm sure you guys get crazy, okay. So very difficult to understand. So the more difficult to understand, the more complex the system it is, okay. So this is not a good way to, and has his own drawbacks also, okay. So let's say, for example, okay, so I'm not against this thing, okay. I'm not, like, for example, it's not something like a god object. I say that you deserve to die, okay. So this one is a keys principle: keep it simple and stupid. So sometimes this is more than enough. For something like, for example, for some small stuff, for example, extension or something like that, you want to still maintain your dependency control, this kind of thing, you don't need dependency injection. Yeah, you can, for simple stuff, you still can do this, okay. But when things get complicated, this one have his own drawback. Later I will tell what are its drawback. Code complexity, what are the issues with them? The main issue with this one, did I mention that this one is object rarely? No, I haven't restricted object rarely. Let's talk the good thing about it first. The child no longer know the parent directly. Okay, so this one is good. Okay, so because they call through the callback function, right? It only relies on the callback function. Okay, so this is good. Flexibility, you can change the child, and so this one now already your code is testable. Okay, so for example, for the one-way one, at least you can still change the parent because the children is not dependent to it, right? You can swap the parent. Okay. However, still you can swap for the single wave one. You still cannot to swap the children. For the double wave one, you can do both. Easier to test. So this one at least is testable. Okay. So if you want to swap a stuff, okay, you can just pass a mock function to it. Okay. So for example, it means that you just pass a dummy function to it, so you can start testing. But the main issue with this one is the callback drilling. Okay, so in the React world they call it prop drilling. Okay, I think you guys have definitely, if you are from TypeScript world, you have definitely seen this one. Okay, so how the prop drilling it is. So okay, so so this grandparent, okay, for example, want to call something from the child, I believe. Okay, it was something like this. I remember. Grandparent, he pass his callback to the parent. Parent pass his callback to the child. After that, child call like that. Child can call the callback from the grandparent. Okay, did I draw this one properly somewhere? Let's see. Yeah, okay. So it means that like this. Okay, so the grandparent, he passes his callback to the parent. The parent callback his thing to the child. After that, the thing in reverse happen. So yeah, but even that the thing that it reached here, the children just he called the grandparent. Okay, so this one is shit. There is no question. So no, actually this one is not totally correct. So because we just pass a callback function, right? So I have to do an arrow directly from child to grandparent. So I didn't draw it very well. Okay, so my mistake. I will fix it again. So in the video when this one is uploaded, I'm gonna fix this one. My apologies. Okay. So what's the issue with this one? So if the number of the layers grow, so how many layers you have to pass this thing? Okay. Okay. So this one is a very okay. This is extremely hard to manage. Okay. So for example, you want to, for example, the callback function now he only input A. Okay. If you want to now input A and B, okay, this is you have to change the entire thing. Imagine, for example, you want to change two of them in, for example, in 20 layer. Okay. So previously, I remember I exactly have this scenario. So the issue was like this. For example, we have something very lower. There was a machine. After that, for example, we wanted to call something from the UI. It means that we wanted the machine be able to call something from the UI. So I remember that, for example, we have 20 layer to reach to this thing. Okay. So every time, for example, I wanted to upgrade that thing. Okay. So I had a nightmare for for a day. Okay. Because the issue is that you have to pass to 20 level on this kind of thing. It was very extremely difficult to maintain. Okay. So first of all, these things back in the days that I was doing this, I even, for example, this one I was using the dependency injection and I still have this issue. Okay. So the thing that it is that although you use the dependency injection, still if you use the dependency injection wrongly, still you can, for example, something like a derailing still can happen to you. Okay. So for example, for that case scenario that I say that I have the correct solution for something like this. Sometimes it's dependency injection. Okay. So for example, you create a separate service and for example, multiple people access to the, for example, service or something like that. But message buses, okay, for example, something like MQTT or for example, in memory message buses or Kafka. Also, this one also could be another solution. Okay, so there is not only one solution to this problem, but this is a very bad problem to have. And I remember that this one it was so nightmare that after 2 months I don't care about the Scrum, I don't care about anything. I changed the entire thing. I just implemented a message bus and after that connect the thing from beginning to the end. Just go to the message bus directly, go to the observer pattern and those kind of things. Like I remember it was even the message bus. It was not the, for example, the message bus that I built. It was some sort of in-house built message bus. I was quite young. Okay, so this one was dependency injection. So this one is something horrible to do. Okay, unnecessary dependencies. Okay, sometimes, for example, and this one also again too. Okay, so for example, for example, this one another case scenario also I remember. So for example, the callback that I was, for example, passing from one to another, they were not needed. For example, the middleman does not need to have access to that callback function. Okay, to put this one in perspective is like, for example, buying a real estate. Okay, so in a real estate, for example, you have a realtor. After that, you call your realtor. You say that, okay, can you, for example, reduce down the price, this kind of thing. He called the realtor of the seller. After that, he talked to him, can you do, and after that he said that no, you cannot. After that, he talked to his realtor. He talked to your realtor called to you. So it's too much headache, right? So on the message is lost, those kind of things. And for example, for some small stuff, I don't know, for example, something like, for example, I put for example, the letter that you receive, for example, you want to pass the letter that you receive, for example, to, for example, the seller after you bought the house. Okay. You don't need to call the realtor. He called the realtor, his realtor, and he called himself, right? So something just like a passing a letter or something like that. It does not anything concerning with law or something like that, right? So too many middlemen. I believe that even the realtors, they don't need to know about these kind of things. That, for example, the previous owner ex-girlfriend, for example, love him a death wish. So it's not necessary, right? So just don't do this. Okay, just is not main. I would say that the main issue with the callback drilling, okay, is lack of maintainability. Okay, maintainability is a very huge concern with the hardware drilling, callback drilling. Okay, so this one, it come to the stage that we say that the correct solution is dependency injection. Yay! Finally, after I talked so much, dependency injection is the way to go. Okay. But before we start about the dependency injection, okay, let me first. I think I explained the dependency injection first. Okay. So what is the dependency injection itself? Okay. So always when you remember the dependency injection is like plate of sushi. Plate of sushi. Okay. The best metaphor for a dependency injection is a plate of sushi. Okay. Plate is important. The sushi also is important. Okay? Why a plate of sushi? Let me show you the architecture. Okay? In I don't bother me. Okay, a plate of sushi. Okay, why I say a plate of sushi? The reason that I would say that it is a plate of sushi is because first there is a plate. Okay, the plate of sushi normally is your container. Okay, so this container could be, for example, Inversify. For example, it could be Inversify. It could be, for example, if you are in a TypeScript board, it would be Inversify. Or for example, if you're using Nest, it could be the Nest dependency injection. Or for example, it could be if you are, for example, in a .NET work, there is an Ninject Microsoft dependency injection. Could be Dagger 2. For example, if you are in C++ work, you can be Google Fruit, can be Dagger 2. Or in Java world, for example, it could be Juice. So yeah, so this dependency injection could be anything, but the plate, okay, is the container. Okay, well, this one is a plate of sushi is a very good example. Okay, plate of sushi. Okay, the plate is a container. It means that is a place that he holds all the dependencies. Okay, and the sushis or for example all your resources. Okay, these resources could be anything. Okay, so I do dependency injection a lot. Okay, so I'm using dependency injection for many years now. I started using dependency injection I think 2018. Okay, 2018 I started either 2000, yeah, 2018 I was using dependency injection. So it is almost as of speaking today that it is 2024 to almost 2025. So I'm using dependency injection for almost 6-7 years. So the dependency injection is a baseline of the domain-driven design and those kind of things. So, but regarding a dependency injection, mm, you can do a lot of things when it comes to the dependency injection. For example, when I say resources, these resources could be anything. Okay, so for example, the resources could be configuration files. Okay, so I do a lot of nasty things with the configuration files. I do not nasty thing is a wrong word. Okay, what I have to say is that I have do a lot of cool things with the configuration files because I'm using these things for a very long time. So I'm very comfortable. Actually, one of my biggest thing that I did in my previous contribution, my ex company was dependency injection. So before me, there was nobody doing dependency injection in my previous company, and it helped a lot. Okay. So, for example, one thing that, for example, it could be configuration. For example, in a JavaScript work, could be, for example, it could be even functions. Okay, you can inject functions, and even for example, normally the things that we teach the dependency injection, normally we are looking for interfaces. So for example, substituting the interfaces, but you can even, for example, inject implementations. Okay, and for example, injecting implementation is very interesting. Okay, normally, for example, the configuration that I say, normally I inject the implementation as a configuration as an implementation. Okay, so yeah, so that one is something fun. Okay. For example, imagine, for example, you have a service that, for example, want to have a configuration, and you have is a singleton. It means that you have one instance of this through entire code. Okay, and for example, you want to pass your configuration to it. For example, best example of this one is, for example, you have only one database in the system, and for example, you want to get the, for example, connection string or those kind of things. So he has some sort of configuration, those kind of things, right? So, for example, you can inject the configuration file through a dependency injection. Okay, so that is something very cool. So no need everybody have access to, for example, read everything from the environment, those kind of things. I'm very against environment. I did another video also. I think I did the video, or I'm not sure I did the video or I did a blog on it. I will, if later after this video, if I find the things, the resources about why I am against to putting your entire data in the environment variable. Okay, so some of the things, but yeah, you can do a lot of cool things with the dependency injection and those kind of things. Okay, and it is very flexible, but you have to know what you're doing. Okay, so the whole idea of the dependency injection is that you don't have any more hard dependency. It means that the classes, they are not all connected together. Okay, so your dependency graph, it's more look like something like this. Okay, what means it means that, for example, first of all, most of the things, they are interfaces, they don't have any dependency, and the implementation also, the dependencies that they have is something to something abstract, for example, like for example interface. Okay, so this one, it makes it very easy because the abstract class, you can just change it. Okay, so let me I show you the code, because it's, I think it become too abstract the way that I type. Okay, so for example, this one I'm doing it with Inversify. Okay, so I love Inversify for the reason that I hate the Nest.js is because they are coupled with their dependency injection is coupled with the framework. I hate that. I hope that I remember to explain that why I hate that. But never mind. Let me explain why this one, the dependency injection, how it works. Okay, the way that this dependency injection works is that you see, I have interfaces that they have no dependency. I have 3 interfaces that they have no dependency. Okay, my implementation, this one is my implementation. Okay, implementation. Okay, so for example, I have something like iParent. Where's my iParent? Is my iParent. Okay, this parent supposed to be dependent to the child, right? He is dependent to the interface of child. Okay, so if you see in here, okay, my parent is dependent. It means that the implementation of the parent is dependent to the interface of iChild or whatsoever. Okay, so, and the dependency injector, okay, he will inject this child for me. Okay, it means that if, for example, I have, for example, 3 type of children, okay, he decide that which children, for example, supposed to be mine. So I can switch between the children. So one children could be test, another children could be, for example, the actual implementation, or for example, one children could be, for example, MongoDB, another children could be Postgres. Okay, or for example, one children could be, for example, okay, for example, SAML2, or for example, another one could be OpenID. Okay, so this kind of things. Okay, so you can switch between stuff. Okay, so you can have multiple. For example, okay, it can be JSON or XML. And this one is a very good example. Okay, so very interesting. Okay, because for example, for something like JSON or XML, both of them, they're serializing, right? Just although the downgrade is different, but for example, you can in the code based on the configuration. For example, this one is a legacy. This one exactly something that I was doing a lot in my XML. So for example, for the legacy codes, all the implementation they were using, for example, the XML, all the new batches that we sent, everything was JSON. Okay, and thanks to the dependency injection, I can do stuff like that. Okay, but if I didn't have the dependency injection, he write switch case, this and that. So yeah, it became very difficult. Especially one thing that I like to do with the dependency injection, also the environment. In each environment, for example, when I'm wiring it up, this one I will do in another tutorial. I can do 100 tutorial. I can do 100 video. If you guys interested in dependency injection, for example, interest people, I can do 100 videos on dependency injection only. No issue. So for example, on the configuration side, for example, you can switch between this and that. For example, one of the common things that I do is that, for example, on the environment, for example, when I'm in a for example, in my computer, normally, for example, I use normally, for example, something like type ORM or something like that. Okay. So, for example, with the type ORM, the configuration for the type ORM, for example, I inject it for example, the configuration I inject the configuration. Okay. Yeah, so I've used a repository pattern. I don't know you guys know what is a repository, but I can show you the repository pattern also. Let me know. Okay, all these things that I say, if you guys interested, just let me know. I will do a video on. So for example, I do repository pattern. After that, for example, inject the configuration file. After that, you inject the configuration file, for example, in your local environment is in memory. After that, when you, for example, in a production is Postgres. So yeah, so this kind of things, common and stuff. Okay. So you can do all these changes. Okay. So yeah. So okay. So in here, it means that what it means that this I child that it is injected, you don't know what it is. You just know that this I child, for example, if it's for example something like XML or for example JSON, for example, when it's some okay, it's easy stuff. For example, this I child is a, for example, could be JSON or for example could be XML. You know that have only one function, serialize. Okay. For example, for this I child, okay, based on this I child, okay, he just do perform child task. Okay. This, for example, perform child task could be, for example, serializing, for example, XML, or for example, could be serializing a JSON. You don't know. You just know that he do the serialization. So yeah, so you don't care. Okay. At the end of both of them, they do the same thing, right? So okay, it is something like that. So it means that in one place you are determining all the, for example, all the interfaces, all the abstract things. After that, you implement them. But the way that you implement them is that you don't hardly couple them. You inject the things. Okay. But the question is that how you inject the things. You need a plate. Just now I said that it's like a plate of sushi, right? So you have to construct the plate first. In the construction, the plate is that you have to build a container. In building the container, you say that okay, in this code, if anybody wants I parent, pass him a parent. If anybody want I child, just pass him child. If anybody want have grandchild, just pass him grandchild. Okay. So this one is a simple dependency injection. So this is nothing complicated about it. Okay. But for example, you can do fancy stuff. For example, you can pass, for example, to constant. Okay. For example, configuration file. Just now I mentioned it is normally you do to constant. For example, it means that you have a you, for example, anyone asks for this configuration, you just pass him a constant. Okay, so it means that you read it at the beginning of the code. After that, you pass it. It can be like a factory. What does it mean? It means that, for example, based on, for example, you can do something like this. So a lot of dependency. The dependency injection itself, they have a lot of type of dependency injection. But for example, one thing, for example, some of the dependency injector can do for you. Not all the dependency injectors can do this. One. For example, you can pass them parameter based on the parameter that you pass. It give you. Okay, so you can do something like this. Okay, so you can switch. For example, okay, I want this implementation or that implementation. It means that the moment that somebody requests, you pass him, for example, with a string. Based on that string, for example, you decide that, for example, I want JSON or XML. Okay, you can do that. This is very good actually. You may say that, well, why the hell somebody want to switch between JSON or XML? Okay, this is, for example, good for example, what case scenario. For example, you have a many customer. One customer use JSON. After, for example, I remember in the previous jobs, I had a case scenario that, for example, they have some sort of recipe, but so we were working with different factories. Each factory, they have their own recipe, but at the end of the day, all the recipes, they are the same, right? So we created so it was an extension system, it was a plugin system, but based on the plugin system, we were deciding that which type of instance we create. Okay, this kind of shit that I'm speaking of. For example, if, for example, you do, for example, in a God object type of thing, so it will kill you. Okay, first of all, you cannot to create them dynamic. Okay, if you do this kind of things dynamic in the object, this kind of thing, you really have to care about the memory leaks. Okay, make sure you clean the things properly, because your God objects live forever, right? So memory leaks could happen, this kind of things. So but for example, if, for example, something like a dependency injection, for example, you have different type of dependency injection also. If, for example, you have something like, for example, a scoped base. Okay, for example, you have, for example, something like singleton base. Singleton base, it live forever. Okay, a scoped base, it means that, for example, it will die. It means that, for example, after the stuff it finish, he will destroy himself. This kind of thing. So for example, you can do a stuff like that. Okay, for recipe, those kind of things. Sorry, another one, transition based, yeah, something like this. So you have dependency injections that, for you have to read their documentation. So they have different stuff. So You can, for example, you can, for example, make sure that how they are constructed, how they die, these kind of things. You can play with lots of things over there. So this thing is very something very cool. Okay, so what it happened is that, okay, so what, okay, you add this much of boilerplate to get something like this. Okay, that just have I parent, I child, I grandchildren, and the most important thing it happened to you that in this code that you see, okay, you don't know how grandchild is constructed. Okay, because if you know how grandchild is constructed, you have to be dependent to the dependencies of the grandchild. Okay, the beautiful thing is that we don't know how to construct a thing. Okay, if in the world, for example, imagine this grandchild have 100 dependencies. Okay, if for example I wanted to create the child, okay, for that grandchild I have to import all the 100 dependencies of the grandchild to myself. What the dependency injection help you to don't care. What the dependency injection does, okay, what the dependency injection does is this. Okay, you tell me what you want, I give you what you want. You don't need to know how it's done on the background. Okay, this is the whole job of the dependency injection, and this is beautiful. So we improved a lot of things, isn't it? Okay, so this thing is very beautiful. Okay, this thing is very beautiful. This thing is very beautiful. Okay, but since I just did a basic explanation. So before we do this, okay, don't get too excited. So I want to say the bad things about the dependency injection before I go to the good stuff. Okay, I like to say the bad things first. So you have more boilerplates. You see that, for example, okay, just for example, this guy to access to that guy, how much setup I did. So I have a lot of boilerplates. Okay, so this is a main thing about the dependency injection. So dependency injection is not something for some 10 lines of code does not need dependency injection. You're just wasting money and memory and those kind of things. Okay, and especially, yeah. So this one is. So what main thing that you have to remember about the dependency injection? Okay, this is very important. Okay, you have to remember this. Okay, to a man with a hammer, everything looks like a nail. Okay, you have not to be that guy. Don't be that guy. Okay, the main job of the dependency injection is decoupling. Okay, and sometimes dependency injection, for example, can be the solution to your decoupling is not dependency injection. For example, something like message bus could be your solution. Okay, exactly on the first case scenario that previously I mentioned. Okay, so I was passing the thing. Okay, I won't say that the dependency injection solve a lot of things, decoupling issue, reduce on the issue of the decoupling, but at the end of the day, dependency injection is only a tool. Okay, it is up to you how to use it. Okay, if you want to do something like object derailing, those kind of things, it still could happen with dependency injection if you use it wrongly. Okay, this one is very important. Object derailing circular dependencies. Even for example, in dependency injection, you can have circular dependencies and difficult circular dependencies because first of all, some compared to something like God object, okay, circular dependencies in when you do dependency injection happen very rarely, okay, but when it happens, is not very straightforward normally to find it out, okay, because normally we do a good job when we do dependency injection, we do the decoupling, those kind of things. But if a case scenario happen, is a very edge case. Okay, the first time you use something like blah 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 blah, this kind of things, and it is more difficult to find because now already is behind the dependency injection, right? Is behind your container, right? Previously, when you have something like a God object, you just go check the references. After that, you go to see the patterns you can find. But now that, for example, you have something like a dependency injection, you have to really see the logs. There's no way just, for example, with a click of mouse find who is dependent to these kind of things. And for example, even for example, another thing that it is that for example, you have normally you have tools that for example they can give you the dependency graph, right? But for example, when you have something like a dependency injection, no tool can give you the dependency graph that it is. Yeah, they cannot give you that easily. That for example, who dependent to who, this kind of thing. So make life more difficult. Oh, one single dependency. The general issue with patterns like okay, dependency injection. This one is a very good point. Okay. So there is one big issue with the dependency injection, and for example, not only dependency injection. So all these normally these decoupling methods, they are most of them, for example, like something like message bus or for example dependency injection, those kind of things, or they have something similar that, for example, they remove all your dependencies and after that they replace it with one big dependency. For example, mediator to remove all the dependencies. After that, you have dependency to only one thing, and that is mediator. Or for example, something like Kafka, or for example, something like MQTT, or for example, RabbitMQ. Okay, so you have only dependency to the message bus, and after that, you push everything to the message bus and get everything from the message bus. Those kind of things, right? So although they remove all your dependencies and you don't have a spaghetti, but you have one big dependency, and that is your, for example, dependency injection, or for example, your message bus. Okay, for example, if you are new to the dependency injection, I give you in another context. For example, imagine you have something like a Kafka. After that, you want to change the Kafka to RabbitMQ. Okay. Especially, for example, you have a Kafka, you have partition, those kind of things, right? Okay. Or for example, MQTT. Okay. How difficult it is to, for example, switch, for example, Kafka to MQTT. Okay. That is good that you have only one dependency. Okay. It solves a lot of things, but if you want to change that dependency, okay, you will die. Okay. And I will tell you this one for experience because I have done that. So let's go to this example. So the beginning that I was using the dependency injection, I think the first time I did the dependency, I didn't have any method to kind of thing. So I was reading these books, and after that, getting familiar with Uncle Bob's. And after that, I find out that the way to go is dependency injection, and I was not very sure back then that which dependency injection to use. I remember first I used Microsoft one. After that, I see it's not very good. Ninject is better. And then I started with Ninject, so I pay a price to change from the Microsoft to the Ninject back in the days. Okay, Nginx was more fun. So after a while, I see that the support for the Microsoft is more, and Nginx is losing popularity, those kind of things. So I decided to change back. But this time the project was not as small. Okay, so the first time I switched from this to the other one, uh, the project was small, so the time that it took me, it was maybe a week. The second time I tried this one, and we use the dependency injection heavily. Normally, especially in .NET framework, it's not like Inversify. In Inversify, you have all those decorators, those kind of things. So when you use a dependency injection, it is very difficult to switch. But in the C# world, because they don't have the decorators, okay. And this is the reason I hate Java also. They use the decorator for the dependency injection. They are very dependent to the dependency injection itself. Okay. But for example, in a .NET world, you are not dependent to dependency injection that much. However, however, you have a lot of factories, okay, and in the factory itself, you need to, for example, if you use a lot of factory pattern, those kind of things, for example, if they create a complex object, something like that, um, or for example, switching between this one and that one, what will happen to you is that you have to refactor those, okay, you have to refactor those. And when you refactor those, when the project is big, yeah, that is tough. That is tough, okay, because they are heavily dependent to the thing. Okay, it is correct that you are remove all your dependencies, but be mindful about it. If you can wrap your dependency injection itself, that is a good idea. I would suggest the same thing about the message buses also. Try to wrap them. Okay, the reason that I will suggest to wrap even your message buses is that because imagine tomorrow, for example, now, for example, RabbitMQ is enough for you, but for example, the business grow and you become that big that Facebook is nothing in compared to you. And now, for example, you decided to change to Kafka. Okay, how difficult it is? It is difficult. How difficult it is to change to Kafka? Imagine every single, for example, microservices that you use. If you don't have a wrapper or something like that, they are calling to RabbitMQ. After that, now you have to change every single one of them, every single, and that's not easy. So all these patterns that they remove the decoupling, yeah, they are good, but in general, they are difficult if, for example, you change mind. And I would say something like this is okay. The normal way that we do is like dating, and for example, the way that, for example, you go for this kind of dependency control things, it means that removing the decoupling, this kind of thing is like marriage. Okay, so there is no happy ending if you want to break up. Okay, this is what I would say. Okay, on those, for example, just for example, something like, for example, you have only one tightly coupled object. Yeah, so okay, for example, child is connected to parent, or for example, coupled to the child, or parent and child, they are coupled together or something like that. Okay, you just only one dependency, but when you use a dependency injection, and you have hundreds of objects, it is not one object to object. It is tough time. It is tough. And don't forget again, so this one I mentioned many times today, DI is not the only tool for this kind of things. And DI tool can, USC can do horrible things. This one also I mentioned lots of things, but you can still do horrible things with the DI. Still you can have circular dependencies, and I told you can create horrible circular dependencies. And now that you have a circular dependency, this one is a more advanced circular dependency, because you have used tools to find your dependency graph, those kind of things. USC can do the drilling. Yeah, so all these things again, still is a problem. This is only a tool. It is up to you how to use the tool. So I say all the bad things about the dependency injection. Now let's go to the good stuff. So dependency injection is a pattern that injects dependency into the object. So this one definitely you guys know by now. I talk about it so much. Using a framework like Inversify, can you decouple the creation from usage, which makes your system more flexible and easier to test. Yeah, so this one I mentioned 100 times. Testing it become very easy because you can switch easily. This is the most flexible and scalable solution. This one also, there is no question of it. Okay, is scalable because you can easily change this kind of things. They don't know each other. Okay, this one now it explain more. Loose coupling, the parent-child and grandchildren classes are not decoupled, so they don't know about each other. Because they're independency injected rather than directly instantiated. It means that now, for example, you can change the child 1 and child 2, and you don't know. Just as long as you know that how the child works, everything is okay. This allows each class to focus only on its own logic without worrying about it. So you don't need to know any more about that. For example, what your dependency do. Okay, the most important thing is that it is a construction site. Okay, uh, most of the times you don't know how for example, even for example, you have a children inside. It is what it is, as long as you do, for example, correct API, those kind of things. Okay, you do best practices. For example, you don't directly, you have getter setters. Okay, this kind of things. You don't directly write to, for example, a memory. For example, if it's in C++, or for example, something like C# or those kind of things, higher level languages. This one is not a big matter, but for example, if it's something like a C++, you can directly write to a memory of the guy. Right? So, for example, don't do stuff like that. Okay, so these things is not a matter, but the main thing that it matters is that you don't need to know how to construct the object. Okay, what does it mean? It means that previously, if for example you don't have the dependency injection in here that the child come, well, the child was not like this. Okay, the child was more something like this. The construction of the child was something more like this. What does it mean? The construction of the child was something like this. It means that you have to know what to put inside the constructor of the child to create it. Okay? This is horrible. Because why? Because to know what you put inside, you have to know all these dependencies. Okay, so after that you become more coupling and more coupling to other stuff. Okay, so this helps you to just tell him that, okay, I want a sushi, he give you the sushi. Okay, you don't need to know that, okay, how sushi is constructed. You don't need, okay, for example, it's like you ask him a pencil, he give you a pencil, but you don't need to know to go how to, for example, chop a tree, after that trim the tree, after that, for example, how to make the pencil. He just give you a pencil. Isn't it beautiful? Yeah. So flexibility, yeah, you can have different configurations. So as mentioned, for example, the best example of this one, actually, this is the second time I'm recording this video. In the first time that I recorded this video, I was talking for 1 hour and 30 minutes, and after that I find out that my mic is not working. But in the second round that I'm recording, in the first time I give a very good example, and my example was this. For example, imagine you are in a Linux environment and you are in the, for example, Windows environment. Okay, so for example, in the Linux environment, you do the SSH. In here, for example, you do, for example, CMD. Just a stupid example. Okay, so, and for example, you need to do, for example, do some commanding and those kind of things. So you just write one wrapper, and after that, in here you do SSH. Over there, for example, you do, for example, your command prompt or whatsoever. And after doing this, so the interface is injected to you, so you don't really need. So in each environment you have a different configuration. It means that for example, Windows environment, okay, all your services that it is injecting to you, okay, they are for Windows environment. And in the for example, in the Linux environment, all they are like that. But if, for example, you don't have a dependency injection, and for example you have to have messy switch cases every time, for example, in the entire code populate the switch case. I mean, if case, oh, if we were in C, okay, imagine if we were C, we use macro, okay, so if the common. You see, both C and C++, we had the if def, those kind of things. Okay, that is nightmare. Okay, yeah, this nightmare. Dependency injection solve all these problems. Next thing about dependency injection is my love, decorators. Okay, so for example, dependency injection, it allow you to use patterns. Okay, design patterns. Okay, so one of the design patterns that among all the design patterns, a lot of design patterns adopted those, all these things happen with the dependency injection. You can use all these nice things. But one of the things that, especially dependency injection, that saved my my life a few times is decorators. Okay, so let me show you a decorator. Uh, Thanks to the last time doing this, where I put the decorator. Yeah, I think it's this one's, yeah, this one's the decorator. Okay. So for example, imagine, for example, you have a parent. Okay, so this parent, everybody happy with it today. Okay, and tomorrow, for example, somebody asks you to, for example, I don't know, for example, just some edge case scenario happened, for example, after that, for example, you are forced to log the thing. Okay, so this one is something unnecessary. Okay, but for example, somebody comes say that, okay, I have a performance issue. Okay, I want to log you, and you're, for example, you are stealing my time or something like that. What you do is this. Okay, you do a decorator pattern. So because the thing, everything is interface, right? So it's abstract class. So you create another interface and implement this one by calling the original one. It means what? For example, I'm creating the logging parent, okay? That it's, for example, extend the parent. Actually, this one is not a very good example, but for example, okay. Normally I don't do like this, okay? But you know, it's just yeah, this one also not bad actually. He used super, okay? So for example, okay, for example, you have a logging pattern, okay? So every time, for example, the guy he called the interact, okay? You call the original function from the super, is from the original, okay? But before and after, you just log the time, okay? So like this you can do, and in a very easy way, okay? You just can do all the things, okay? But for example, if you don't have this kind of thing, and for example, okay, previously injecting originally the parent, now inside your dependency injection, instead of the parent, you are injecting the logging parent. Okay? Man, that is cool, man. That is some cool shit. It saves a lot of time. Okay, this one is logging is, for example, is a very stupid case. Yeah, I remember one case I had. Suddenly, something happened. The customer requested to uh, put some sort of error handling. Okay, for this case scenario, do this and this kind of blah blah blah. This kind of thing. Okay, these things saved my life. Okay, if I didn't have these things, man, it took forever. it had took forever. Okay, so you can do design patterns, and among these design patterns, the ones that I find out very useful, that it give you the flexibility rather than reinventing the wheel, those kind of things, is decorators. One of them. Okay, also, definitely you can do wrappers, those kind of things. Yeah, so. But one of the things that it saved my life a lot is decorator. Okay, you can do chain of responsibility. Yeah, not only decorator. For example, you can do chain of responsibility, those kind of things. Yeah, you can do a lot of things. Okay, it opened the door for you. You know, and it's just it give you the flexibility to do the shits you want. Okay, but if you don't have dependency injection, you cannot do all this. It has its good, it has its bad. It is a tool. You have to know. Okay, is a knife can kill people. Is a double-edged sword. You can kill people with knife, or you can protect your wife with the your sword from enemies. Okay, it is up to you. For example, okay, you can kill your wife. I would say like this. Okay, you can either with a sword you can either kill your wife or you can protect it against, for example, enemies or something like that. It is up to you how you want to use it. So scalability, as the system grows, you can easily or replace dependencies without modifying the existing code. So this one is very easy, especially just now also I said about the object, the God object, right? So when the thing is become complex, and for example, this kind of thing, people don't dare to change it. Okay, they don't understand the thing, they frighten, they break the things, this kind of things. So make the thing more scalable. People they can scale the thing. I'm gonna do one tutorial about how to do this one with the ChatGPT. So scalability. Yeah, I do a lot of ChatGPT, so this one also I show you. Let me know in the comments if you want to. I do a lot of cool shit with this ad. Coma. I do a lot of cool shit actually. I don't know you guys watch this one or not, but if you guys watch this one, yeah, I do some interesting stuff. This is worth sharing. Testability. Okay, with DI you can easily mark the things. So this one I mentioned I think 100 times already. You can switch between these and for example simulation, the factory case that I told you in COVID. This one it was very simple with the dependency injection. If that thing happened, for example, you just change it to simulation environment and this one you can inject mark child and those kind of things exactly like my factory scenario. And you have separation of concerns. Everything is okay. It makes it more understandable, maintainable. You don't have psychological issue anymore. Your boss does not fear you to your push for the next next stuff. Increase the reusability. The parent class does not need to know about the child class. This kind of thing. Okay, can actually create and manage. This improves code reliability and make the system easier to maintain. This is true. This is exactly opposite of the callback running and the callback. Yeah, so this one also is true. The parent class does not need to worry about the child. Yeah, so they don't need to care about each other. So this one is also. So okay, so this is the end of the presentation. I hope you guys like it. In the next presentation, I'm gonna show you uh, how to do a simple dependency injection in Inversify using NX and Inversify. This one was an introduction. I'm doing the NX Inversify and TypeScript, and the stack would be something like that. So I hope you guys like it. By the way, I'm in Upwork. If you need help with anything, or if you have any project that you want, you can find me on Upwork. And I put a lot of affiliation, this kind of thing. You help me so don't die of hunger, so I can do videos like this. Please let me know if you have any concern, anything you learned from this, or anything. You see me, I'm like talking to you like I'm talking to a person. I'm like your friend, so I like to know more. And if I'm doing any mistake, please let don't be this one way thing. So I teach you. I hope I can learn from you guys. If you have better ideas and you are more senior than me, I'm always have willingness to learn from you, and I appreciate. And I would like to if you teach me something new, I would like to share that one with others also. So spread the knowledge around. So thank you and have a good day.